Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bumpers. It's a fun show where we take a deeper dive into robots and their teams and what makes them function and work. And today I'm here with team number 3130, the Airs out of Woodbury, Minnesota. This high-powered team has 5 regional wins, 3 regional finalists, a division finalist, and did have an opportunity to play last year at the Great Northern Regional in 2020, where they were semifinalists. And today I'm here with Connor, Tomas, Ria, and Maddie. We're going to be taking a deeper look into the modifications they made on their 2020 robot, some of their COVID outreach they had as well too, and their programming, all here on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. So Connor, we're going to be taking a look at your 2020 robot here that you modified for 2021, and you're going to be running through some of the mechanical features on it. So we're going to take that power cell journey that we do here quite frequently on Behind the Bumper. So let's start out with your intake. Tell me more about it, what makes it function, and how it's worked out so far for you.
Yeah, so we use a 5-wheel pneumatically actuated beater bar intake. Tomas, if you want to show that. So what happens, pick up a ball. Okay, so it's pneumatically actuated, it goes up and down, and we also used non-stick wheels, very hard rubber wheels, because we decided that we didn't want the balls to get caught in it like we had happening when we were first prototyping.
Yeah,
after that,
something to follow up on that is what difficulties have you had with that? So you had some balls getting stuck in there. Can you describe a little bit more about that and how you iterated past that?
Yeah, absolutely. So when we first started designing last year, the biggest problem for us was the ball sticking to any wheels that we used to try and pick them up, as well as each other. So what we found was the best was using hard rubber wheels for an intake, and then using an HDPE film everywhere that the balls were touching that wasn't actively trying to move them. So with our hopper floor, it's an HDPE film, as you can see in here. And we used a rotating hopper system to help cycle the balls around so that they don't get caught on each other.
So do those rollers, are they both going in or are they going opposite directions? How do those work?
We use opposite directions. We have one going in at a high speed and then the other one going out at a lower speed.
Sure, so it just kind of continually jostles them, right?
Exactly.
So I do have to ask you a strange follow-up. What's with the 2175 ball that you seem to bogart there?
Actually, we share a shop with Team 2175.
Oh, okay. So you're not just stealing their power cells or anything like that?
No, we're not stealing the power cells. We share most of the things in our shop, including power cells and game pieces.
Okay, fair enough. I'm sorry. Continue. Let's talk about the shooter a little bit.
Yeah. So after the balls are in the hopper, once they get cycled through, they go through an indexing system that sends them up into our shooter. And something that we changed about the robot going into the 2021 season was this fully adjustable hood here. We used to have a pneumatically actuated hood to get 2 angles, but now with this, we can get any angle that we need to get dead center in the target every time.
So that's kind of interesting because some other teams that we've talked to have actually switched more to the 2 position instead of the multi-angle, because with the at-home challenges, you only need to, in many cases, shoot from a couple positions. Can you talk a little bit more like what true advantage you saw going out of that? Like, I know there's an advantage of having multiple angles, right? But what have you actually seen happen from having multiple angles like that?
Well, when we competed last year with 2 angles, we found that we weren't able to hit dead center from further away, which would be a problem this year, given some of the challenges require high scores from hitting the center. And we actually built this shooter before the season shut down last year, right after our first competition. So since we already had it built and ready to go, we just needed software for it. We decided it was worth the time to put in and use it during the at-home challenges.
And can we see a couple power cells cycle through the bot, and can we see them shot out, and let's see how that looks with the shooter as well? Well, very, very cool on that. I really love that. That looks like it's about, is that 180 or 270 degree shooter on it?
We have a 270-degree turn, so we can go all the way back and point up over the robot as well.
Cool. So we're going to move over to Tomas here, who's going to be talking about some of the software on the robot, and more specifically in regards to these changes have been made. Because Tomas, I know going from to a fully adjustable shooter from just like 2 stages can be a big change in that. So I want to hear more about that, and then anything else that's gone into your robot that you want to show off from a programming standpoint.
Sure. So previous year we had this turret here, then we had the limelight tracking the target, and as you heard Connor said, we had a problem with hitting the ball in the middle every time. And what we were doing to like calculate the speeds for the ball is we had a shooter curve using some like real data points and seeing what speeds we're hitting. There's a lot of variability. So with the hood now, we can be moving it and the speeds. So there's less variability in where the ball is hitting on the target.
So do you have some preset ones that you use, or is it just varied based on what the limelight is returning back, or how does that work?
So we use the distance the limelight gives us, and we have a curve we build. We just get some data points. I think we go every 10 inches, and then we have those points linearized in code. So then it can get the distance based on the limelight, and it'll know the speeds and the hood angle it needs to be at.
Can you talk to me about some other sensors that are being used on your robot as well?
Sure, of course. We use a Falcon drive base, and then also Falcons for the shooter. The limelight here is what we're using to track the target on the ball and keep the turret tracking. We have an SRX with a mag encoder to keep the turret position with a PID loop, and then on the turret itself to handle when we should be shooting, when we should be tracking. We have a state machine that is handling all of that.
Sure. And one thing I like to ask some teams, and I know this maybe a little bit not quite in your ballpark for things, but I always love seeing the electrical setup on robots as well too. So something I want to ask you, and hopefully you'll know on this, is that where does electrical packaging come into consideration for your team? Is it one of those things where it's like mechanical designs everything, and then you got to try to figure out how it fits afterwards, or do they give you some consideration and not just give you everything last minute?
Well, we're very lucky in that our build also does a lot of electronic things, so we're able to kind of compromise as we're building. But at least in my opinion, it usually does come up to being we try to fit what we can mechanically, and then we build electronics around that.
Sure. Fair enough on that. So we're going to be wrapping up here talking to Ria, and Ria is going to be covering what 3130 has been doing in regards to outreach during COVID times. And I know, Ria, one of the things that you mentioned is that you've actually been actively using your robot to actually show off during COVID, and it's been benefiting you from a COVID outreach. Can you tell me more about that?
Yeah, so what we've been doing is throughout the summer, we spent around over 50 hours actually partnering with a program in our community called Sawashko Cares. There, we not only handed out food to families in need, but we also introduced kids to STEM as we handed out sanitized STEM kits for them to do at home. And then we did a large robot demonstration. So we not only had first flyers to hand out that were all about local teams they could join, but then we sanitized our controllers in between each person, and we allowed them to drive the robot,
Oh, wow.
pick up balls, shoot them, like catch them and play with them. Just, bring the community together during these tough times.
Can you detail a little bit more what was in the STEM kits that you handed out?
Yeah, so one of the options was a parachute, a parachute device. And I definitely think Maddie would be able to explain it a little bit more as our outreach lead.
Yeah, let's bring her.
Exactly.
Let's bring her in on it and see. So, Maddie, tell us a little bit more about the STEM kits that you had.
Yeah, so like Ria mentioned, we had a parachute, and it was an easy, you just cut out paper and tie some string with some glue. And then we also had we had bouncy balls that a teacher at our school helped us to make and get. And then so it was just things like that, easy STEM kits that kids of any ages could do at home, no matter if they had parental help or not. And it was just a way to introduce STEM to students at home safely since we couldn't do a lot of our normal STEM stuff over the summer.
Well, 3130 The Heirs, thank you so much for taking the time to tell us about your robot, the modifications it's made, and how you're tackling the at-home challenges, but then also how you're tackling COVID at home as well, too, and having a positive impact to the community. So thank you so much for taking the time, and wish you best of luck the rest of this season and, of course, in future seasons as well.
Yeah, thank you.
Thank you.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.